Hi, it's the Hawaiian shirt coder here again, continuing on with our Web API series. We've gone a long way along the road to building a complete solution, but now we're going to start adding some infrastructure. And by infrastructure, I mean a database. Let's take a look. So here is our current design. In the previous video we looked at adding a level of abstraction to our data through data transfer objects, and that all worked well for stopping potential breaking changes. Now we're going to have a look at how we can actually start using a real database as we continue on with our improvements from demoware to a more production ready Web API solution. So this is what we're looking at in this video, is how to get rid of this in-memory list that is acting as our database at the moment and actually use a real database. So here are the learning outcomes. By the end of this video we'll have a basic relational database in place that holds the data for our sports management system. That is fixtures, availability and players, which will be good because most of the examples I've given so far have been using the player entity as the example, but this will have all three in place, and it will also have the relationships that exist between a player, their availability and fixtures. So a fixture can have one or more availability entries. An availability entry must be for a fixture, and a player can have one or more availability entries, and the availability entry must be for a player. So it ties the two together, and by having this actual database in place, this will let us continue on our road to breaking up the structure of our Web API into more logical tiers and single responsibilities, which at the moment we haven't got, as everything is based in our controller. So rather than this in-memory hard-coded list, we're going to actually use a database, and we're going to use either SQL Server Developer Edition, or I'm going to use SQL Server Express, which either of those was a prerequisite if you were following along with this course. What you will notice is I have added one further project to our solution called SMS Database, and this is so we can quickly and easily get a database up and running without going into the nuts and bolts of how we've created the database and all of that, because our focus for this series is Web APIs. It's not how you create databases, of which there are several different approaches. That may well become a future series. So what I want here is a low friction barrier to getting a database up and running without much explanation of how I created that database. But if you follow this script, you'll be able to install on your local SQL Express or SQL Server Developer Edition on your machine the same database as I'm going to show you now. So let's get started. So the first thing you need to do is you need to go over to View, and you need to pick this one, SQL Server Object Explorer. Now, out of the box, when you install Visual Studio, you get a database called LocalDB. We won't be using that one for this series. What we will be using is, in my case, SQL Server Express. So we need to go and add that in. So how you do that is right click, add SQL Server, select local, and this will show all the local databases that it thinks I've got on my machine, database servers I've got on my machine, and MS SQL local is this one that's here, and for some reason it's repeated my SQL Express ones, but that's fine. We just pick that one and we go connect. You will notice we get an extra node in our view that is our SQL Express database server. We expand that out and look in databases, we have no databases. So the first thing we need to do is create a database, and this is really the only manual step you're going to need. So you right click on there and go add new database. I'm going to call this database SMS for Sports Management System and click OK. Now you can expand that out and you can see we've got a load of other nodes, and the ones we're interested in are to do with tables. We have no tables at present. So at this point what we need to do next is we need to go to my new project called sms.database and expand it. And all this does is it houses a single SQL script that will create a player table, a fixture table, of an availability table, which we haven't spoke about very much so far in the series, and it will populate it with some dummy data to get us started. And that will basically be this video. So what we do first of all is we double click on this, and we're not interested in all this GUI up at the top, we're just interested in the pure SQL. Like I said, I'm not going to explain what this is, that's for another series. All we want to do is actually copy this script, and this script is doing two basic things. It's creating our table structures, players, fixtures, availabilities, and then it's populating them with some information that looks very similar to our in-memory list, but has a little bit more information because all of a sudden we've started to add some fixtures in and also some availability data, which is here. So we need to copy this with Control A, Control C, close this window again, and actually open up a new query window in our SMS database, and we do that by right clicking, go new query, then doing Control V to paste what's in our clipboard, and then if everything works correctly, just pressing the triangle to execute all these SQL statements against the new database. And we get lots of little confirmations in this window of what it's done, but the main thing to go and do is go back to SMS, right click, refresh, and all of a sudden we've got some tables. So we can close this window, don't save, and our script looks like it's probably worked. Let's just check we've got some data. View data, there we go. So there's our players, view data on the fixtures. There are our fixtures, and let's have a look at availability, which won't look very meaningful. It's a series of IDs, as it is the link table between a fixture and a player. So a player may be available for more than one fixture, and a fixture may have one or more players. So it is the link table in between. To make more sense of this table, I'm actually going to write a bespoke query. Please don't worry if you don't understand the actual SQL I'm writing. It consists of a 3-table join. Like I said, this series is not to do with SQL. That will be for a later date. It is just so you get a better understanding of what this availability table does. So let me just write a new query. So now we'll just shut these windows, and we right click up here and go new query, and then we go select star from, let's start the fixture end, fixture as F, join to availability, that's this one, and it's gone blue, which means availability is a SQL reserve word, so we need to encase it in square brackets. I'm also, because I like it to look the same, is do this in the correct case. Also helps if you spell it correctly. There we go. And we'll give that an alias of A, and we'll say they join together based on f dot id equals a dot fixture id, and then we need to do another join to the player table. So we go join player as p on p dot id equals a dot player id. And we won't return all the fields back because that won't help us very much, but we'll return some to make the data look a bit more meaningful. So from the fixtures table we'll get the opponents that we're playing, and we'll get the date we're playing them on, data fixture, and we will get the player's first name and the player's last name. And what we will finally do is order it as well. So we go order by f dot data fixture ascending, and that will give us the up and coming fixture first. So let's just run this, and there you go. So you can see for the fixture against Southampton on the 23rd of January 2023, these people have made themselves available to play in that game: John Smith, Peter Parker, Ben Stokes, Harry Kane. Whereas when we play Liverpool on the 24th of January, only Peter Parker and Harry Kane are available. So that's what the availability table does. So now we're in a good state for doing away with our in-memory database and starting to construct all our infrastructure that will talk directly to a database. So that's a wrap for this video. Let's have a look back at the learning outcomes. So we've now got a SQL database up and running. We've used SQL Express. You can use SQL Server Developer Edition. In theory, you can use whatever database you like. But be warned, if you don't use one of the Microsoft ones, you may need to tweak the SQL I've supplied in the GitHub repository. So now we're in a position that we've got a SQL database. We can actually start breaking up the application into logical tiers and do away with this fat controller. So here's our new design based on what we've done in this video. All of a sudden our in-memory database has been replaced with an actual SQL database. What we need to do next is actually rewire things up to speak to this SQL database. So at the moment our code is still talking to our in-memory database. So what we need to do next is devise a data access layer that will allow our code to talk to the SQL database using SQL statements. So I'm the Hawaiian shirt coder. That's the end of this session. Please remember to like, subscribe, share with your friends. Remember, keep learning, keep exploring, keep developing, and I'll see you next time.